Test, 1, 2.
Okay.
Mr. Rose, time's up.
Okay. Okay, so thank you for coming. Today we're going to talk about performance troubleshooting, not necessarily related to Alfresco, though we will include some real customer cases. But my goal is that you can walk away with a simple workflow that you can follow to be able to identify quickly the problems that you're having, instead of just saying Alfresco is slow, blah, 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 etc. So this is the agenda for the presentation. We got a short introduction. Then we are going to talk about just the objectives of the presentation. Then we're going to try to identify and model the system as a whole, including all the components and everything. Then we're going to define what load we want to apply to a certain system. That would be maybe familiar to most of you. And then we'll get to the core of the talk, which is what can we do when we have a possible problem against the test plan. So we'll talk about measuring, monitoring, profiling, tooling, and some real customer cases. And if we have the time, we can do maybe some interactive diagnosis of the problem that we are going to talk about. And then at the end, we will have a Q&A session. So if there is anything that I say that isn't clear, please feel free to raise your hand and say, I didn't understand it. Though we do have quite a bit of material to go through, so if you have a more general question, it would be best to hold it until the end. So just as an introduction, my name is Romain Guinot. I'm based in Paris. I've been a solution engineer for Alfresco for about 3 years. I was working for the partner before, so I've been involved with Alfresco for about maybe 5.5 years now. I've been doing mainly pre-sales, consulting, a bit of development and documentation. My Twitter handle is @RomainGuinot, and my email is first name, last name @alfresco.com. I don't want to be spammed, so I didn't include the actual email. So just as a quick survey, has any of you been confronted with a performance problem that your boss asked you to fix? Raise your hand if you did. All right, cool. And was it easy or was it difficult for you to find it? Let's say, if it was easy, raise your hand. Okay, that's cool. So hopefully the presentation will be useful. So as I said, what I want to do is have you guys have a better understanding of the system as a whole in terms of architecture, all the different components, everything. And then when you have an understanding of this, have a better focus of what you need to do in which situation, and just follow workflow and say, I'll start with this, and then I look at this, and then I look at that. And then that will be the problem without even looking at the code once. So that would be cool. And that will result probably in less frustration if it's hard to do. And then decrease time to problem identification, which I think everyone wants. So the first section is just trying to model the system. So the most basic definition that we can have is this, I think. We have client activities that create a demand for some system resources, and then it results in response times that are within or exceeding state tolerances. That's the basic definition of what's happening when you have some people accessing a given system. So I'm not going to talk about Alfresco architecture in detail, because this is going to be talked about in Gab's presentation following mine after lunch. But I just want to make an example of how complex an architecture can be. And then you need to understand that it's not by looking at the code that you're going to fix a problem, because it can be quite complex with everything's going on. You got the clients, the web tiers, maybe multiple shares. You have load balancing. You have the different Alfresco repos if you have clustering. And then you have the indexing and the clustering, all that stuff that's going on. Plus the storage with the DB, probably NFS storage for the content store and not for the indexes, obviously. And so they can get quite complex. So if you look at this in a more architecture physically, you'll have the separate servers for the clients, or separate machines. Everybody on his own machine will be accessing a load balancer that's giving maybe one share or multiple shares. These shares will be load balanced against multiple Alfresco servers for the cluster, maybe multiple sorters if you want to have load balancing. Everything is going to a load balancer. Then you have the database. Maybe the database itself has some clustering built in. You have the storage type, that would be maybe NFS. So that can be quite complex. So we need to have a simple workflow that we will be able to follow. So if we look at the different components of the architecture, just, that's the brief description that's probably known to most of you. You got the disk, you got the hardware, you got the disk drive, maybe it's SSD, maybe it's a standard drive. It's got different types of sizes, different type of technology, different type of connection to the actual motherboard, so that can be pretty complex to figure out. You get different types of memory, different in terms of size, in terms of type, in terms of bandwidth, which is something that most people usually forget. You have some different types of CPU, in terms of technology, has changed dramatically in the last 5 years. So yeah, now you have multi-threading, multiple cores, extra type of caching, L1 cache, L2 cache, L3 cache, etc. So that's going to be pretty interesting. You have the network bandwidths and the latency of the actual network between the clients and the servers and between the different elements of the actual infrastructure. And you have some extra stuff, maybe a RAID controller if you're using a SAN or a dedicated RAID controller in your server, some dedicated hardware, load balancers, all that sort of stuff. And on top of that, you would have some software. You have the OS, maybe it's Linux, maybe it's Windows, Solaris, the JVM, which could be the Oracle one, the IBM, whatever. Some custom applications interacting with your Alfresco repository, and some external systems that you don't necessarily have control of, which would be the database, the indexing, Solar, etc. And for all these hardware components, you must not forget that they have limitations, meaning that you are given a set of static hardware, and that's what you have to work with. So you would have finite capacity for all these elements that we just mentioned. So if you cannot upgrade it, you have to work with it. And if you're putting too much stress on one component, that will create serialization and queues on that hardware. So this is something that you have to work with. And you'll have a finite throughput, whether it's the disk or the CPU or the network. This is something that you have to work with, and if you can change it, you have to fix what's actually using the hardware. So as I said, if you can upgrade it, that's fine, but at least you have to upgrade the thing that is actually the bottleneck. For example, if you are putting more CPU in a system that's not using the CPU, it's completely useless. And then your boss says, oh, you made me buy new CPUs and it was useless, blah, blah, blah. So that's not the thing you want to do. So once you've defined all these components and you are given a set of given architecture, you have to apply some load on the system. And how can you characterize the load on the system? I would say there are 3 types of usual testing. Either it's load testing, meaning you know the load that you're going to have and you just want to see if your system will cope with that anticipated load. You can have a stress test, meaning what happens when you didn't plan the correct load on the system and you just way over the load that you want to apply to the system. That would be what happens. The system crash, the system just gets slower. What's happened? Does IT have to restart some things or kill some queries, whatever? And you'll have the endurance testing, which is, okay, it's responding well for half an hour, but what happens if we let the system run for 2 days, for example? Does it completely crash? Is there a decrease in performance, or does it stay stable, which is what you want during the business hours? So once you've defined which type of test you want to define a test plan that is as realistic as possible. So you want some think times that are variable, random, maybe a Gaussian function, depending on the test tool that you are using, because obviously it's not realistic to put all the queries at the same time in the server. So you want to model what your user are actually going to do. Maybe you have different type of users that will do different things in the system. That would be something that you have to model, because if you don't model the load accurately, you're not testing what your users are going to be doing on the system. You want to have a realistic ramp up, because it's not realistic to put 100 users immediately on the system at T0. This is something that we have already seen and obviously doesn't really make sense. So you want to have something realistic about that. You want to be sure that you are sequencing your action and pauses realistically. And this is something that you have to watch out for. For example, in JMeter, a classic error is to have the samples, the thread samples, following the test and the pauses. Because if you don't put the pause attached to a test action, what it will do is that it will do query, 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 wait, 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 which is not realistic. What you want is query, wait, query, wait, query, wait. So you have to be careful about that. In it's a classic issue. You need to put the pause attached to a test action so that it makes sure that the pause are sandwiched between each of the queries. But whichever tool is used, this is something that's very classic, and it's a problem, so please pay attention, is that usually people say, well, I'm just getting the average response time, and that's completely useless. Because what you want is 95th percentile or maybe 99th, depending on your requirements. You want to know the variance to the mean, standard deviation, all the stuff for stat geeks that are really cool. You can measure stability on all that stuff, because just getting the average response time is not really interesting. It's not going to model what your users are going to see. It's one measure, but it's not enough. So once you've defined your test plan, what is the basic chain of events that's going to happen on the system? So you have end users that are going to make application requests, and that application will translate those requests into local instructions and maybe calls to external systems, which is the database or the storage, for example. Then you have the JVM in between. This is his role mainly will be to translate those instructions into OS and machine instructions and bytecode and memory management for the actual objects. And then underneath, you would have the OS that does the core allocation if you have multiple cores on your CPU, and you will have context switching between maybe more of the cores. Memory allocation, provisioning of that memory if it's well done. Disk I/O, network scheduling. Also, one thing that's not mentioned is locking, because all the locking is a native activity, but we'll talk about that a bit later. And then beneath that, the OS will actually invoke the hardware with the limitations that we just defined before. So that's basically the chain of events that you have to work with during your test plan. So once we've said all that, I think what we need is navigation among all these different components. So when you consider the architecture, the hardware, the users, et cetera, maybe you have batches, external system. What you need to know when you are investigating the problem that you are currently facing is to have a simple workflow that you can follow and say, whatever the problem is, I'm going to start looking at this, and then I look at that, and then I look at that, and I'll collect this info, and that would be the problem. Because if you just look at the code and say, that's not very good, yeah, maybe it's not good, but there's no way of telling that it is actually your problem. So this is what we're going to do in the next slides of the presentation. And what you want to do is to identify the problem, aka what we call the dominating consumer of the actual CPU, and then you solve this problem. And if it's fine, then you're done. If it's not fine, you iterate and find the next problem until you are okay with the response time. And if you do that, I think you'll have less frustration and decrease time to identification, maybe half a day instead of 1 month, which is something that we have already seen. So this is the core of the presentation, I would say now. We need the section about measuring, monitoring, and profiling, and about that actual workflow that you will need to follow. So this is, I would say, the actual workflow. So the first thing that you want to look at would be, how's my CPU behaving? And when you identify the CPU, is that you have to distinguish, and that is very important, the system CPU, which is actually the kernel mode CPU, everything that's related to maybe I/O, network, locking, everything that's a native call, and the user time CPU, i.e. the time that is spent in the actual process. And sometimes people say, my CPU is like 20%. Right? It's completely different if it's like system's CPU is at 20% or user time CPU is at 20%. The problem is going to be completely different. So this is something that the first thing you have to distinguish is this. And we'll talk about a bit later about the tools that you can use to distinguish between these two. Then we'll have to talk about the kernel and the OS interaction. If you have a system CPU above maybe 10%, that means that you have to look into everything that's in contact with the OS, meaning I/O, network locking, etc. We'll talk about this. If it's not the case, and you have CPUs that are still doing not much in terms of system or user, then what you want to do is take thread dumps, because something is preventing your CPUs from actually using them. So you want to know if it's an external system blocking you, etc. We'll talk about this one afterwards. Then if you have a CPU that is close to 100%, then that means that what you need to look at is garbage collection. This is the first thing that you need to look at, and capture the GC log and identify if it's a problem with the JVM, which might be that it's misconfigured in terms of sizing, in terms of generation sizing, in terms of promotion of the objects between the generations. And we'll talk about that specifically later in the presentation. If it's not the case and you have CPU 100%, then it's probably something with your application, meaning an algorithm that is not well designed or something. So we'll talk about each of these bits in the presentation in the next few slides. So the first thing that you need to look at is what is happening when your system CPU, what you want to determine what's your actual usage of the CPU in terms of system CPU, user CPU, etc. And the tool that I usually use for that is VMstat. That will have that's available everywhere. I will mostly talk about Linux or Solaris. I'm not really familiar with Windows, but that's the same workflow. You just need to use different tools. So VMstat will be for all the cores, and MPstat will give you stats per core, which is also interesting because sometimes you could have one core completely maxed out and the others doing nothing, and VMstat will say 12%, but you won't know if it's like 12% on non-cores or one core that's 100%. So you need to differentiate between the two. So if you use VMstat, this is what you will typically get. I think, who has used VMstat before? Raise your hand if you did. Wow, I expected more people. All right, so that would be interesting. So this is a command line tool that's available by default on every OS, be it Linux or Solaris, and you have basically the same thing in Windows, except it's graphic, so I don't really like it. So the first column you would have what we call the processor. So how many runnable threads do you have currently, and how many block threads do you have at the same time? So meaning, if you have, like, for example, as it said in the slide, runnable threads higher than twice the number of cores, probably you're having CPU starvation, and we will investigate that later. Block processes is processes waiting on something else, maybe it's I/O, but it can't proceed until something happens. The memory section we'll talk about a bit later. The swap section is interesting because the swap in, swap out is a severe performance cost. And something that I see people not knowing about is that on Linux you have a kernel parameter that's called vm.swappiness, and that says to the kernel, until how much memory is used can I start swapping stuff. And on the Red Hat systems, it defaults to 60, meaning at 40% usage, he will start swapping stuff out. So if you say, for example, I have a 8 gig system, I gave 5 gigs to the JVM, then immediately at startup, I start swapping stuff. And that's really bad. That's really, really bad. And I've seen that times and times over. So you can adjust that setting to say, for example, 5, meaning go to 95% of your RAM before considering swapping stuff out. The other thing that you have to consider is that, it is not shown on that slide, the kernel, the Linux kernel, will also use some amount of memory for file system caching. And that is useful. For example, Lucene is pretty sensitive to that. So you need to adjust the system and adjust your JVM memory, and we'll talk about that a bit later, so that not only you are not swapping, but also you're leaving room for the file system caching and the kernel and all that stuff. So really pay attention to vm.swappiness. If you haven't changed it, please do. And inspect if you have some swap memory. That will be really bad, and maybe you'll have like 10 times worse performance if you start swapping. So that's something you need to consider. You can configure it in etc sysctl.conf. Just put it in there, and then do sysctl-p to take it into account without rebooting. The next section would be the CS, the CPU section at the end, and the system section at the end. If you have high context switching, CS, that means that threads are jumping from one core to the other. And if you have too much of that, it means that for some reason, the kernel has to eject threads from the CPU to put something else in its place. So you have maybe too much things going on at the same time, or you have maybe they have to be waiting about something, whether it's network or it's I/O, or you have too high of a locking. Maybe you put too much synchronized in your code, and the thread has to spin out of the CPU very quickly, and that's very bad. So the section that we arrive at is CPU. This is what I was mentioning. The US and SY columns are the user time and system time. System time is the kernel mode, aka the privilege mode. Sometimes it's called privilege mode in the CPU, and this is the thing that you want to look at first. So if you see like 20 consistently on the system, then probably this is the thing that you want to look at immediately, meaning I have something problematic with my OS relationship. ID is idle, i.e. Doing nothing. WA is wait, meaning waiting on something. Usually it's wait blocked on I/O, for example, usually. And ST is not supported on all kernels, but it means how much time of that core was actually stolen from another VM. So if you're using Xen, it will be supported. If you're using VMware, I am not sure. But this is something that is interesting. If you were given a VM and you see a high number of ST, this means that another VM is actually using your own CPU more than you should. That's something they should work about. So the first step is, for example, what happens if you have high system CPU or system CPU that is about the same as user time CPU. This is the first symptom. So if that's the case, you need to investigate the OS interaction. So is it because the I/O is saturated? You can use IO stat for that. You can also use VM stat as we showed before. If it's the network, you can use netstat, which is available by default. There is another cool tool that's called nexstat. It's not available by default, but you get more stats, and you will be aggregating stats over a short period of time. So that is interesting to find out if you have any errors regarding your network. Is it overloaded? Is there any issues with the hardware resulting in dropped packets or etc. If it's not network I/O, and if it's something regarding component in the kernel or something else, there are pretty cool tools that you can use. You can use dtrace on Linux or oprofile, and you can use strace on Solaris to find out what is actually using all that kernel time and get some profiling about that. Some people are also using GDB, so it's a bit more geeky. So I would recommend using one of these three. If it's a problem with locking, then you would want to take thread dumps, and we have an example later about that specifically. So far we just talked about the above portion. Now we're going to talk about the bottom portion, the node dominator, meaning if you have CPUs that are doing not much and you want to find out why is that. So what you would do is thread profiling. That is the case. You want to do that if you have, as I said, low system time, low user time, and of course, if your response time is above what you want. Because if it's fine, then there's no point in taking a thread dump. So what you want to find out is what's preventing threads from consuming more CPU. Is it block threads? Is it synchronized locks? Is it high I/O latency, net latency? Are you waiting on external resources, maybe the database? The tools I would use for that, TDA. How many people have used TDA? One. Wow. Okay. So that's pretty cool to get to analyze some of the thread dumps that you would take on your JVM, whether you did it with JStack or whether you did it with kill-3 on Linux to get a thread dump. Then you can analyze that thread dump with TDA in a more graphical way. Another cool tool is YourKit. Probably most of you are familiar with YourKit. Raise your hand if you did. That's more people, okay. But the cool thing about YourKit thread profiling is that you will be able to take threads in a running fashion. Instead of taking just samples and analyze and trying to catch the problem, you will have a graphical view of the threads over time with different colors, and we'll see that just a bit later. And that's a pretty cool tool to find out precisely what the problem is. So for that, we have an example. So we have a customer who had a custom front end and then Alfresco on the back end and complaining about very poor user performance. So what we did is that we started by profiling the back end. Nothing much was happening. And then we decided to provide the front end, which is something that they never did. And this is what we saw. So obviously, that is not good. So the red blocks are meaning block threads. The threads are waiting for a lock if it's red. So as you can see, one thread, the one I highlighted, was fine, was doing something because it had the lock. Everything else was pretty much blocked and doing nothing. So when you provide that, you click on the red button anywhere on the graphic, and you will get the thread dump for that, and it will tell you what lock it held and where in the code is that lock held. And what we found out is that they had changed our own code and added synchronized to most of our own methods. So that is not a good idea at all. So we took that out, and that was much fun afterwards. But they were complaining, and no one has thought about profiling the front end. Obviously, created a lot of contention for the users because everyone was waiting for a lock. And this is what we saw in the back end, pretty much nothing happening. So when we fixed this, there were still some issues with some performance. And what we did is that when you click on, I don't have a screenshot for that, but when you click on one of these elements, you will have a thread dump that will tell you what it's waiting for. And in that case, we were waiting for the DB for most of the time. So we'll talk about that now. But just a summary, if there is not much happening, what could be the cause? In this case, it was because the front end was so massively synchronized that it created a lot of contention for the users. So the Alfresco server wasn't actually receiving much requests because it was one at a time, when someone was managing to get the lock, obviously. So when we reduced that, we were waiting for the database most of the time, and we are going to talk about that now. So if you have an external resource like the database, sometimes the problem is that you have different teams, the DB team and the storage team and the application team, and sometimes they're not really talking to each other. So what's cool about the tool we're going to talk about is that you can use that without touching the DB at all, and you can do some cool profiling. So the usual monitoring issue is lack of DB access or lack of proper access to put the profiling on the DB. And the problem also you can have is that you can have the DBA say, well, everything's fine on my end. The queries are really fast and exiting the DB quite fast. But maybe something's happening between the DB and the actual server, because the user is not going to care if the requests are coming out fast of the DB. What they want is that the web page loads fast. This is what they want. They don't really care about who's at fault here. So something that is interesting, I think, is to do some profiling of the DB, but not on the DB itself, but from the application server, so that you get an application server point of view of what's going on with the DB. And for that, you can use P6Py to collect some stat. Who's used P6Py before? One, okay. It's a DB driver that is available. It's open source, and it's a DB driver that you can use in place of your actual DB driver. And what it will do is they will delegate the actual queries to the driver you're currently using, but in the middle, it will log all the queries and the response times for all of the queries. So when you have that log, what you can use is the tool we're going to talk just after. You can use a pretty cool tool to do some analyzing of that log and some aggregating the queries and finding out which are the queries that have the most impact on your server, meaning the queries that have, when you multiply the response time of the queries multiplied by the number of times they were run, and then you take the percentage of that compared to everything else, you can determine what is the impact of a particular query on your own server. And then you can get an explained plan for the query and maybe optimize it. So there's a wiki page on the Alfresco wiki that you can find out. I wrote it. That explains everything about this. in a technical, practical way. But we are going to use an example afterwards. What is cool about it is that it's pretty lightweight. All you have to do is putting a jar in, and that's it. No complex setup, and you can do the analysis on another machine. So you only need to collect the log, and that's it. Then you take the log on your laptop, and you can analyze it and do whatever you want with it. Currently, it uses a system current time release for P6Pi, so that is still statistically relevant if you have a large body of queries. It won't necessarily be precise for one event, but you don't really care about the performance of one query. What you want is to find out what's going on for a large volume of queries that's going on during your test plan. And it's even more relevant if you have significant network overhead between the DB and the app server, because it's always going to be larger than 1 millisecond. So as I said, it's pretty simple to configure. There's one property file that you need to put in, for example, Tomcat share classes, or the equivalent if you are using a different app server. Just say, what is my actual DB driver? So maybe it's MySQL, or Postgres, Oracle, whatever. Just tell it to log to a file, and that will be it. And in your Alfresco global properties, you just need to say, I am using the P6Pi driver instead of the one I used to go directly to the database. So it's a low overhead, but be aware that it can have large files pretty rapidly. So you need to make sure that you're putting it on the file system that is A, fast, and B, significantly large to hold the log. And if you use the tool to analyze this, it's called PT Query Digest. It's coming from the Percona toolkit. Who is aware of the company Percona? All right, cool. So what's P6Pi is that I added a parser for P6Pi in their own toolkit. And then you can use that to get some pretty cool stats about the DB. So as you can see from a customer example, what you can see here, I don't know if the pointer works, but it doesn't matter. So you can see the rank of the query in terms of response time overall for the duration of the test, the time in percentage that it represented for the whole test, the number of times this particular query is called, response time on average per call. AppDex is a statistical measure that you can have to measure the user experience, meaning how many queries were below the expected response time and how many queries were between 1 and 4 times the expected response time, and have a measure. The variance to mean, that's cool if you want to measure the stability of the query. And then you have an aggregated query. So if you have a query with different values, it will still count as the same type of queries. For example, a delete on that table with this type of query, as you'll see later, will be counted as the same query. And this is very useful because sometimes when you have some profiling tools, it will give you all the queries, but it won't do the aggregating. So what you want is to see, okay, for example, query number 1, 36% of the time I was in there, and we only called it 100 times, and it represented 36% of the time. And that's and what is strange about it is that it's a delete, and should be taking so much time. So as you see, these tables, if you're familiar with Alfresco, are the locking tables. And what this guy had done, as it's indicated in this slide, well, the next slide we'll talk about it. So just, sorry, I forgot something, yeah. So you have 2 modes of profiling for that tool. You can have either a summary view, that's this one, and if you want more detail about one specific query, for example, if you want more info on query number 1, then you have the detailed mode. And the detailed mode is pretty cool because you can have a time distribution in time buckets. So you can say how many queries were about 1 millisecond, 10 milliseconds, 100 milliseconds. So you can find out pretty graphically and with no dependency what is the average stability of my query. Is it always in the same time bucket, or is it varying wildly? And this is something that is very interesting to know. And you will have for this query, you will have an example of the actual query that was run. And if you know this example, you can just say to your DBA, can you give me the query plan for that query and find out if there is a missing index or something. And this is something that is very pinpointing because without any dependency and without any complex monitoring, you can find out exactly if there is one query that is hitting you very hard. And then you can just identify what the problem is and find it out. Is it because your statistics are not up to date? Is it because there is a missing index? Is it because the query plan is bad for some reason? And this is something that you can tell the DBA without actually doing anything on the DB. So in that customer case, what they did is that had added 2 pessimistic locking to their own code. And so everything was done by trying to acquire a lock on the DB for some particular query. So, and that was not realistic for that scenario. So what they did is that they took this out. The app was reviewed. They moved to optimistic locking, and that was fine. No problems whatsoever afterwards. So you see, with just 2 thread dumps and DB profiling, in about maybe 1 day, we were able to find out 2 issues that they fixed, and everything was fine afterwards. So that's the first step. So what's cool about PT Query Digest is that there is also other parsers that you can use. It can parse TCP dump for MySQL wire protocol. So you can have some information about the network overhead if you compare the one with P6Pi and the one with TCP dump. You can also parse Postgres log, MySQL general log, slow log, and some cool stuff about memcached. And you can also do some profiling with HTTP and try to find out, to profile some of the HTTP queries and get time distribution for your HTTP queries. Okay. A note about time resolution. I need to speed up because I'm quite late. There is system current time release, nano time. It's all native calls, so that's only completely kernel dependent, and the JVM spec cannot guarantee anything. So watch out about that. It's good in Solaris in Linux. It's pretty bad in old Windows, so make sure you know about this. It may not be precise for one specific event, but what we care about is a large body of events, and then it will become statistically relevant. So we're talking about these 2 steps. Now we're going to talk about the middle one, about GC logging. I'm going to speed up a bit because I'm late. So this is you're probably familiar with all of this. The JVM has different generations, the old generation, the new generation, survivor spaces, permgen, and what's going on is that it's allocated in the Eden, then it moves to survivor space, but it's copied over maybe a bunch of times, depending on your configuration, and then it moves to the old generation. And what you can find everything about that in the GC logging. And this is something that people not usually doing, but you can leave the GC logging in production. It's pretty low overhead. It's about a couple % on top of the actual GC overhead. The GC logs are pretty small, so that's not a problem. You can get very, very valuable information about the life cycle of your application by turning on the GC logging. So this is something you really should be doing. You can turn it on with these sample options. You can find out later. Java 7, maybe if you're not familiar with this, can use rolling log files. It was a problem with Java 6 for people leaving it on for 6 months. Now you can just log around maybe daily, or depending on size, or depending on number of files that you want to have. So this is interesting. For people who have Chuck Norris skills, you can read the GC log manually. So you can find out the red bit is the GC type that was going on. The strong yellow is the heap before in the generation in question, heap after, and the smallest yellow is the generation size, and the green is the pause time for that particular event. But if you're not Chuck Norris, there is some pretty cool tools that you can use to find out, to analyze the GC logs, and the one I prefer is HP JMeter. Anyone has used that? No one. Okay, so it's free. It's available on the HP site, and you can find out some pretty cool graphs about heap usage after GC. We'll see that later. GC duration over time. What's going on over time? Maybe over a period of 1 week. Does my GC slow down for some reason? Creation rate, meaning how fast am I allocating objects over time? Am I hitting hardware limits for some reason? And many other graphs. Something you need to be aware of is that in JDK 7, the decimal format for the GC log change. So HP JMeter does not understand natively the GC log file for Java 7, but you can easily fix it. I usually use sed, and I put in an example to fix the log and make it understandable by HP JMeter. what you can derive from the GC log are the application and versus JC time ratio, heap sizing, is it appropriate or not, generation sizing, is it something that I can change about this, premature promotion, meaning I'm copying objects from the young generation in the old generation, but if I left it a bit in the young generation, it would have been eliminated because the cost of collection in the young generation is much cheaper than in the old generation, so you want to size them appropriately. Tenoring threshold is meaning how much time I'm copying it in the between the survivor spaces before I'm moving it into the old generation. Heap usage after GC is the graph that you want to use to investigate memory leaks, and we'll talk about it just after. And creation allocation rate with regards to your hardware limits. So the first example would be heap usage after GC. This is just an example of a deliberately undersized heap. I just started Tomcat with 96 megabytes, and obviously it's not going to work. So as you see, the full GC to GC ratio is like 95%, and you're spending like 75% of time in GC. The purple bricks are the times when the JVM has to stop completely to try to do something. So it's kind of an emergency mode, and obviously if you see that, something's wrong with your GC. So I just included that example because you need to be careful about calling out a memory leak. Sometimes people yell memory leak, and in fact, it's just the JVM configuration that was bad. So you want to look out the full GC to GC ratio, heap sizing with regards to the working set size, progress over time, and the object surviving too many collections. So I have a cool example. Can anyone tell me what's going on here? 5 minutes, okay. So no one, maybe. So what's cool about this is that at 3 a.m. something happened. And at 3 a.m., if you know, in Alfresco at 3 a.m. there's a Lucene backup job. So what's going on here is that for some reason the Lucene backup job was allowing the heap to free the objects. That is interesting. So in this scenario was pretty unusual because it was people doing only read-only searching during the whole day and absolutely no writes. So that's pretty strange. So what we did to analyze this leak is that the general method to analyze a memory leak is this one. I summarized it here. What you want to do is analyze the GC log and this graph, heap usage after GC, and then you want to use maybe JVisualVM to find out the collections, how many objects are surviving, maybe too much collections. You want to use allocation strike traces, find out the paths to the GC routes, meaning why are those objects still there. You can use this JVM option are pretty cool because you don't have to trigger the dump manually. You just have to wait for the JVM to be out of memory, and it will dump the heap dump automatically. In that graph, that's interesting that the Lucene backup job managed to find it out. And as you can see, in the heap dump, I'm using your kit, and for some reason, there was like 900 megabytes of exceptions of stack traces, because they were using stack traces to find out something. And as you can see, it will tell you the allocation stack trace back to the GC root. So you can find out that this is the class you want to look at because there's 900 megabytes retained, and it's a bit strange. So you look at the code, and you see that instead of a remove, there is an add, just a typo, something that you would never find by just looking at the code. But if you look at the right information, then you see, oh, it's obvious. So you just debug stacks were retained but never discarded. So that's something that was fixed, and then problem solved. So that's pretty cool. So the last thing we need to talk about, I think 5 minutes? 2 minutes? Okay, that's fine. So the last thing we need to talk about is application profiling. I don't have an example for that, but that's the easiest case. If you have high user CPU, low system CPU, meaning there's something about, and there's nothing wrong with the JVM, it's probably execution profiling that you want to do. Usually it's done with attaching a VM agent, such as your kit, and you can get some sampling or tracing CPU and find out what algorithm is using all of your CPUs. Since I have 1 minute left, there's a bonus topic that's pretty cool. If you want to know the VM flags that change between release to release, because this is a problem that we also had, people upgrading the JVM and the behavior completely changed. You don't want to put in thousands amount of flags in your JVM config. You want to start with a minimal amount because sometimes people are just tweaking the flags, and adding 50 flags, and it doesn't make any difference because there are people at Oracle whose job it is to make those flags obsolete. So what you want to know is minimal amount of flags, but still, if you want to find out what flag changes happen between release to release, and you don't have access to the source, what you can do is that you can extract out all the VM flags by running strings on the .so, libjvm.so, and then when you have that, you can use jinfo, which is provided by the JDK, and for each flag, tell it to give me the value of that flag. So you would have all the values of all the default values of all JVM flags for a specific release, without having to the source. So that's pretty cool. There's about 7 or 60 flags in the latest JDK 1.6. I don't know all of them. And there's about 800 in the latest JDK 7. So there's some pretty crazy stuff going on. But it's still interesting to compare from release to release the flags to know what has changed, when I was added, something that was turned on, that was disabled before, new code. That's interesting. Questions? No questions.
You stunned them.
0 questions. Ah, okay.
You'll have to excuse my voice. You haven't talked about the client side,
Yes,
JavaScript.
Well, it's only 1 hour, so. But you know, there's something you can do. Yeah, there's a lot of things you can do on the client side too. You want to measure maybe the latency between the client and the server. For example, you know, if the server is in Texas and the clients are in Paris, for example, maybe there's something you want to monitor using the network net latency tools. There are some tools that you can use. Also, there's a strategy that without tooling, there's a strategy that you can use. It consists of replacing selectively components, and in that case, that might be running the test close to the server, so that you would find out, is there something going on? If you have good response times when you're running the test close to the server, and very poor response times when you're far away, maybe there's something going on in between. Maybe it's hardware, maybe it's latency, and this is something that you would investigate then. Is that okay? Okay. All right.
Must be lunchtime.
Okay.
Thanks very much.
While we're living here, let's get this little one thing clear. There's plenty of men to die, you don't jump, you turn. And it's 1, 2, 3 on the wrong side of the lead. What were you meant for? What were you meant for? And it's 7, 8, 9, you get your shuffle back in line. And if you ever make it to 10, you won't make it again.